Hey, I'm Drew, and this is the Terminal Element. Today I would like to do some show and tell about this self-contained Starlink Mini case that I built, and we'll be utilizing the lessons that I learned from all of the mistakes I made on mine to build my wife one from this virgin, fresh Apache 3800 case from Harbor Freight, so that hers will be perfect while mine sucks, because that is how a marriage works. So I've got the Starlink Mini here, which is a complete setup with the dish and the wireless router, and it is held into the box with these 3D printed mounts. And these mounts can be twisted so that we can remove the Starlink if for some reason we ever have a need to do that. I anticipate keeping it in here the vast majority of the time. This works directly through the case and there's no issues. Now, to power it, I'm using the Anker C200. You can see here, I've got pass-throughs for the XT60 solar charging port, as well as a couple of the USB ports. In addition, I have some cutouts for spare cables and things here. Now, if we look on the side, pass-throughs, which is probably the most anxiety-inducing part of this, but we have here a pass-through for the XT60 port, as well as the USB ports. Got a USB-A and a USB-C. When I want to turn this on, all I need to do is just push my finger in here through the foam, and there's an on button. A long press turns on the power, and a long press turns it off. For our large components, in addition to a Starlink Mini device, we'll need an Apache 3800 case from Harbor Freight. And to power this, I'm using the Anker SOLIX C200. Now, you could use any power supply that you want and can fit in the case. However, you'll need at least a 65-watt USB-C PD for power delivery output. These 3D printed mounting components I printed from PETG Filament. Now, I ran into a couple issues. I made some mistakes that left me with some practice parts. Don't use ironing. Ironing did not work out for me. Perhaps I was doing something wrong, but you know what? It came out just fine without ironing. I used normal supports rather than the tree type supports, and we'll chip out the back of those here in a little bit. Additionally, you'll find two separate plans on Maker's World or wherever. Don't print the one that uses the bumper on the Starlink Mini. That just didn't fit well into the Apache case, so just stick with the normal, standard 3D printing mounting plans, and I'll put a link in the show notes. For tools, we'll need a cordless drill, a soldering iron, a hole saw kit that I got from Harbor Freight, and some more drill bits that I probably also got from Harbor Freight. You might have noticed a pattern by now. And we'll need to buy some threaded inserts. Now, what these are, little brass rings with threads on the inside, and we stick them onto the soldering iron with a little special adapter, and we melt that into the 3D printed part so that we can put screws into it. And so it came with this tip, this adapter. So you'll need the type of soldering iron where you can pop off the tip and insert new components. Now, the plans called for a 6mm diameter threaded insert. I made a mistake and I used 5.5mm. That's what I ordered on accident, and it worked more or less okay. For cables, I have a Starlink Mini power cable. This came from eBay. One side has the DC port that plugs into the Starlink Mini, and the other has a USB-C cable. I have the USB-C to USB-C cable that came with the Anker SOLIX, and 90-degree adapters for the USB-C. Got female to male. Okay. Now, for the pass-throughs, I have the XT60 Passthrough. This will go straight into the SOLIX. I have a USB pass-through with a USB-A and a USB-C port. There you can see the female components on the other side. And a USB-A to USB-A cable that goes to the pass-through. And lastly, this is optional. My solar panel has an Anderson Powerpole output, so I just needed an adapter to plug into the outside of the case. You could just as easily put some adapters on the inside of the case and do it Anderson Powerpole pass-through, but this is the way I went, and it's working. For fasteners, I'm using this E6000 glue to attach those mounts to the inside of the case. Now, you could probably just as well go with your own favorite glue, but this is what was recommended by another user in the comments of that Maker's World listing for those 3D printed components. And because I didn't want to make a ton of mistakes and have to redo this and possibly damage a case, I just stuck with what they recommended and what was known to be successful. There's also a recommendation for a certain type of tape in that listing. So if you want to go to the tape route, just log in that and you'll see what I'm talking about. To attach this XT60 Passthrough onto the case, I'm using number 10 machine screws with a tapered head because that tapered head just fits right in here real nicely. And on the other side of that, I have these nuts with a nylon washer insert. Now, in hindsight, I wish I'd have gone with a little bit longer than a 1/2-inch screw because I don't think it makes quite the best purchase into that nylon washer. However, this is also not a part that gets a ton of vibration, so it's probably not at high risk of backing out. Now to attach these 3D printed cross pieces that hold in the Starlink Mini, the plans call for an M4 screw with a hex type head, and that just fits right down in here. We'll do a little bit more finagling off camera. You got to screw them in a little bit, and then those will go down into those threaded inserts that we melt into the 3D printed mounts. To start off with, the stickers on these cases drive me absolutely bonkers. You cannot easily pick these off. We're going to need to drill through at least one of them, and so I'm going to be using some Goo Gone here to release those up. And so what I found, just put a little bit of the Goo Gone stuff on here, let it sit for like 30 seconds or a minute, and it'll end up just peeling right off. All right, so we'll just glue this Goo Gone right onto this sticker. All right, it's been about a minute. Still a little tough. All right, more goo juice. That's better. First try. All right, a little bit of juice and a good wipe down. I'll get the rest of that sticky stuff off of there. All right, now on to the other 15 or 16 stickers on this thing. These ones are nice because I can just pool this goo juice right on the top of it. Is this not a sticker? Oh yeah. Yeah, you get off there, you naughty little sticker. You're a bad sticker. Next. So I think what I want to do now is install the pass-throughs for the XT60 port in the USB, because if we did the mounts first, the glue takes a couple days to dry, and also if I go to all the effort of installing the threaded inserts and gluing on the mounts, and then I screw up the pass-throughs, I don't want to have to throw everything away and have to print new mounts and everything. And then I think we'll set this pluck foam aside and do it last, because, well, I wasn't going to get into this, but I guess I have to. I suffer from a medical condition. I have pluck foam anxiety.
Pluck foam anxiety, or PFA, is a silent disease suffered by Zoomers, Millennials, and Gen Xers across America, but not Boomers. If you're a Boomer and you bought your house for $10 whole in the 70s, paid it off in the 80s, and retired in the 90s with a genuine pension and Social Security, you can afford all of the extra pluck foam you need when you make a mistake. But for millions of PFA sufferers, the pain is real. There is no cure for PFA. So if you see a bro with a new Harbor Freight Apache case, and that sad look on his face like his dog was just flattened by a Peterbilt truck, just be there for him. Let him know his pain is seen.
So here we are in the inside of the new case, and we're going to be doing some measuring and marking before we do any drilling. And now, longtime viewers of the terminal element know that as far as accuracy goes, all we need is for it to be completely perfect! And so I'm going to line it up with these lines on the inside of the case. I think that is just about as perfect as we're going to get. So previously, I put this pass-through, I lined it up with here, and that did not really give me enough space. So I think we're just going to scoot it over like there. Why not? Kind of towards the middle. Okay, do we have ultimate perfection? No. But am I going to be able to live with it? No. See if I can mark it out with a Sharpie. I'm going to drill through from the inside. Then we'll have our holes on the outside, and I can use those to mark the center. I'm also using a really small drill bit so that if I did screw this up, I can come through with the larger one and maybe just widen it out and Figure it out then. All right, wish me luck. All right, moment of truth. Let's see if this lines up. Yeah. Yeah, that's looking really good. The holes are really close. Bottom left one concerns me a little bit. Might be slightly low. That's okay. I will screw in the other 3, and then I'll send the drill through the bottom left one. So now, in order to more or less find the center, I'm going to draw a cross. And this will all be covered up by the final product. Okay. Ah, I did it. Okay. All right. Let's figure out what size hole saw we need. All right. I think I'm just going to have to eyeball it. I can't remember which one I used before. That one. Yeah, that's gonna be a good tight fit. I think it's that one. I ground at it by hand with the drill a little bit just so that it won't wander off that pilot hole. Okay, wish me luck. I hate it, but we'll live. Looks like 3/16 does a good job of reaching through this hole. All right. Hold on to your butts. I'm liking the look of it. I do see that we have an issue on that bottom one. I'm just going to go ahead and send the drill bit through with it like this. And I think everything else will be fine. Let's just do this and not think about it too hard. All right, Leroy Jenkins. All right, we're good. I'm gonna pull that out. We'll bolt that in after. You know what? Probably like after we're all done. So here's my thoughts with the XT60 in. I want the USB port pass through to be at least a ½ inch away from it. I want there to be a ½ inch of plastic here supporting these devices so that we're not eroding the plastic away or warping it or something. So to get this perfectly in the center, I'm going to draw 1 inch from the edge of the XT60. To do the same thing up here, although, oh, that's going to be a lot rougher. Let's go here. Now, Goo Off, or Goo Gone, or whatever we want to call it, actually takes off this Sharpie. So I think if I draw a line, just draw some lines here, I think we'll be okay. Be fine. No one will notice, probably. And what is it? That's about 1.5 inches, so 3/4 of an inch will be the center. And it actually is complete perfection if you don't think about it too hard. So right there on that line is where we want to drill. Right, everybody? Right? Right. Okay, we're going to start off by drilling a pilot hole again because I really don't want this thing to wander when I drill the larger hole. Okay. And I ended up going with the exact same size hole saw as, goodness, as the XT60. Get in there, you puke. Okay. Oh, why is that wobbly? Why are you wobbly, sir? Okay. I don't like that. Whatever. All right, here we go. Yeah, that's great. That's perfect. All right, let's clean this up. Move on to the next step. So preparation of the 3D printed part starts with chipping out. You can probably barely see it here. There is some support material that needs to come out. Now, if I claw up this backside, this is actually the part that's going to be glued down to the bottom of the case. So I'm not so worried about that because I'll never ever see it. But you know what? I'll know about it. So I'm still going to be careful. But this gets all chipped out. What we're looking for is be able to see a nice clean hole, the hole through here, right? So the idea is we chip this out and then we're going to be melting those threaded inserts with the soldering iron all the way through the back so that the tip top of them is just peeking out the top of this piece. I don't know why it's done that way. I'm very new to this, and so I am just following instructions. I had a number of issues with the threaded inserts. Let me grab one and I'll show you real quick. So the tool that it came with on my soldering iron, I hope you can see this. It's a little tip. It's a little tip, and this actually, I don't know why, but it comes unscrewed. So presumably you could buy other little tips to put on here, but you want it to be a nice smooth tip so that you can melt it in and then pull the tool out. But I thought, well, I should just use the biggest one I can get. And so I put it on and I melted it in. Here's the issue. There's so much here, threads exposed, that weren't covered up by the tool. They weren't protected by this pin here. And so I had plastic melting into the threads, and that was absolutely awful to get out of there. I tried screwing in one of the screws to clean it out. That just generated so much heat from the friction that it melted the plastic more. And so this thing was just spinning around and I had to remelt the thing. It was just not good. So I think I'm going to use the smallest one. But even then, you'll see there's still quite a bit of threads here that are exposed. So I don't know how this is going to go. It may be just as much of a nightmare as it was before, but we'll just see. I don't really have any other options at this point. Okay, I've got my soldering iron heating up to 200 degrees Celsius. We don't want to get it too hot and just be setting things on fire here. And I've got the threaded inserts set into place where we want them. When I'm confident that that soldering iron is hot enough, I will melt those down straight through until they make contact with the table, which I will be using my wooden desk this time instead of the dining room table. All right, I don't feel like waiting anymore. I'm sure it's hot enough. All right, let's do this. Here goes nothing. I did not like that. Let's take a look. It actually might not be so bad. Okay, let's do the other one. I did not anticipate it was going to melt up on top of the tool like that, but yeah, I guess last time I used longer threaded inserts. But let's just go for it. Let's just do the thing. Nope. Okay. And I think that's is that all the way down? I don't think it is. Yeah, that's so tough to tell. Now, in this case, I've got like a disc of plastic there. I might be able to just knock that cleanly out or unthread it. Not now, Jim. Yeah. You know what? Let's just clean this up and see how it looks. If I have to remelt it, I will. Well, that took a lot of off-camera finagling, but I slowly but surely ground these screws into the inserts using a 7mm socket, and I just went real slow, and I took turns alternating between the two holes here so that I wouldn't generate so much heat, which, as I mentioned previously on my last build, unseated one of the threaded inserts and caused a lot of problems for me. So it did not come out perfect. It is not how I would have preferred this. Guys, if you've got any advice for me on how to handle these threaded inserts properly, I'd love to hear it. I'm very, very new to 3D printing, but I think we have it to the point now that we can start gluing these parts to the inside of the case. Well, I lost the microphone during the filming of those final scenes, but do you really need to hear me talking about gluing stuff? The highlights are I gave each piece a good smearing of that glue, that E6000 glue, and then I stuck it in right where it needs to go. And I went ahead and left the Starlink Mini in place to help weight those down overnight. I was able to remove it the next morning. The glue itself takes 1 to 3 days to really cure for full service. It's been long enough that I think after I'm done talking here, we'll be able to go finish up the project. Additionally, inside of each one of those blue caps, I had to drill out that screw hole a little bit and then put in the bolt and dropped in a little drop of E6000, smashed that cap on, and things were good to go. So this is a radio channel. Why on earth then am I talking about Starlink? Well, I resisted adopting any form of satellite connectivity for a long time simply due to the cost, but with the release of Starlink's $5 a month standby plan last year, that put the Starlink Mini into a territory that was far too affordable to ignore. So the plan is $5 a month, unlimited data, but you are capped at 500 kilobits per second. And sometimes it'll go a little higher than that in the off hours, but that seems really slow. However, when you think about it, that is 10 times faster than when many of us were kids. And it's plenty for emergency communication. I can do signal messaging. You can do FaceTime. Some people use it to watch Netflix or YouTube, any form of streaming service that has video compression. Some people online are using it for their primary internet, which I think is pretty cool. Now, it's certainly not my primary choice for internet, but it is nice to have an internet box on the go that only costs $5 a month and is easily stored in our cars for if we break down somewhere where we don't have cell service and the radios aren't quite working. Now, I can't honestly say that if Starlink had been a thing when I first started my VHF digital radio project, that I would have continued on with it, that I would have invested the thousands of dollars and hundreds of hours in R&D to set that system up. Now, I'm very proud of what I was able to accomplish, what I was able to learn. We have deployed it in actual extended communications grid down emergencies, but a Starlink would have been just as good. And it rarely goes down. I have had Starlink go down for maybe a half an hour at a time, whereas the radios can be quite frustrating to troubleshoot when something goes wrong. And in fact, it might be impossible for my family to troubleshoot some of the issues that go on. Now, that's not to say that Starlink is the end all to emergency communications. We do have some serious international threats to the Starlink constellation. I just read in the Amron intelligence brief this week that China is developing weapons, space-based weapons and sea-based weapons, specifically to kill Starlink satellites. In addition, Russia was previously known to be developing satellite killer weapons. So these are real threats, and it may not be there forever. So here's what my PACE plan looks like currently. We have our primary, being our cell phones. We use Signal for our primary communication app. And it has the double check mark system where if you send a message, you get 1 check mark, and if it's received, you get 2 check marks. So if we don't get that second check mark, we know then to move on to the next step of our PACE plan, which is everything else. We have to keep all options on the table. And it's not just as simple as we would move to amateur radio, then move to GMRS, then move to this or that, and I'd communicate with HF home. It's not that simple because amateur radio, for example, can't be used by my kids. It has a pretty substantial gatekeeping test that's required for reasons that I really can't quite defend, you know, and my kids are just not there yet with the math and memorization required to pass that test. So that's out of range for them unless they have one of their licensed parents over shoulder. GMRS they can use, but that's pretty limited in range and capability. So what do we do in that situation? Well, it's such a complex situation depending on who's using the radio and where we're at that we just have to turn on everything and hope that something works. All right, what do you think, Nico? Should we go inside and finish our project? Yeah, I think we'll go back in. Okay, here it is. Not the best, not the worst. All of the pieces are glued into the correct places, and it does hold the Starlink. These glue boogers here that pushed out from the side of this piece do fall a little bit short of my goal of complete perfection, but I'm concerned that if I screw with them now, I will end up messing up the whole thing. So I suppose if glue boogers are the worst problem that I have going on in my life, I'm doing pretty good. Okay, so let's now install the pass-throughs, and then together we will conquer my fear of pluck foam. So I've got the foam from the other box for comparison, and I am just super curious if the placement of those pass-throughs is going to mess with this, and I don't think so. I think that's going to be good. We'll curl this over a little bit here, and I think this isn't going to be too weak here. Yeah, I think we're going to be good. Okay, so we're going to take the other foam, and we're just going to use it to match this, with the exception of I think I took a little bit too much off the side on mine because I left some space for the 90-degree micro USB ports in there, and I'm not sure that that space is needed. So we're just going to go one fewer rows here, and that'll give us more strength in between that and the compartment for the spare cables. Got the edge, which is not removable, and then 1, 2, 3 in, and then 1, 2 down from the top, and then 1, 2 up from the bottom. So I'm just going to replicate that here. Hopefully you can see this. 2 down from the top, 3 in from the side. Let's just verify, because you can't unpluck it, as my friend Brian would say. He's a fellow pluck foam anxiety sufferer. Hey guys, you won't see it in this video because I totally forgot to mention it. There's actually 4 layers of foam that come with the Apache case. There's a bottom solid layer of foam, 2 layers of pluck foam, and then a top layer of egg carton foam. Make sure you get that solid bottom layer of foam in there below the power station to protect it. Also, just be aware there is no room for that top layer of egg carton foam, so you'll have 3 total layers of foam. All right, now let's verify how far over we're going. I did a total of, oof, this is looking rotten. 1, 2, 3, 4, 5, 6, 7, 8 spaces over. Okay, so we're going to do 7 spaces over. Okay, let's see if I am going to need to take that other column out. It's probably tough to see here, but we've got 3 USB-C ports. The top one is 15 watts output, which is almost useless to me. The middle one is 100 watts output only, and the bottom one is 140 watts input and output. So I'm going to put a downward 90-degree angle on this and an upward 90-degree angle on this. Now, originally I had wanted to mount this like this, and so I could see the screen, but this XT60 is too tall, and the 90-degree angles I was able to find for it were just no good. So, okay, let's fold this over and just see if we have enough space here. You know what? I think that's actually not that bad. I'm going to leave it. Let's do the other cutout for the spare cables. Actually, 3 in from the right side and 3 in from the top side. I'm going to go ahead now and install some of these cables. On the USB-A, I just went with the one closest to the XT60, so I had to remove less foam. And I'm using the cable that was designed to go with the Anker so that I have a cable that's rated for what it's able to do. Okay. And the Starlink Mini cable up top. USB-C has a lot of excess, but we also have some space over here to deal with that. Okay, this one gets a little curl. Okay. How's that look? Okay, next layer of plug foam, which looks a little bit different because we needed a bit of a cutout for the XT60 and the USB-A port. So that one, I believe I did do only 7 across. 4, 5, 6, 7, yeah. So we're just gonna basically match the bottom one with the exception of these cutouts here for those cable ports. So 2 down from the top and 3 in. Now for that cutout, it's like 3 up from the bottom. It is 3 wide and 2 tall. Now what I noticed on mine is this cable was wanting to cut through here, so I'm almost kind of wondering if I should just sneak that up through the corner now. That way it doesn't cut my beautiful plug foam. Let's just make a hole here. Yeah, that looks good. There we have it.